Welcome to Study Loop.
So we have a hollow cylinder with a light flexible rope wrapped around it, and we're trying to find P, which is the force that is acting on the rope. So we have the weight, so we have a hollow cylinder with a weight of 40 newtons. And then we have the radius of the cylinder, 0.25 meters. We have rope, we have D, 5 meters, because the rope is being pulled for 5 meters. So this would be our linear displacement. And then we're going to say that the force is equal to P, whichever force is acting on this rope. We also have a linear velocity of the rope, which is 6 meters per second. We'll just call this V. So we have to, at this point, try to see the energy balance. So according to the law of conservation of energy, energy initial equals energy final. And in the beginning, we have kinetic energy initial, potential energy initial. Both of them are zero because initially the rope isn't moving and there isn't any potential energy as well. So these would be zero. And then we would have work due to other forces, work due to force P, essentially. And then this would equal kinetic energy final plus potential energy final. The potential energy final is zero as well because in the end, the only energy that we have after the rope has been pulled is kinetic energy. So here, the work here would be FD. So work, the formula for work is force times displacement times cosine of theta. Theta here would be 90. So, theta b here would be 0 degrees rather. So cosine of 0 would be 1. And we are left with the force P times the displacement D equal to the final kinetic energy. Here, the only kinetic energy that is present is going to be kinetic energy rotational kinetic energy rather. And the formula for this is going to be half I omega squared. So at this point, let's find omega. So omega would simply be the linear velocity of the rope divided by the radius of the cylinder. So this would be 6 divided by 0.25. And this is going to be 24 radians per second. At this point, we can say that the moment of inertia for a cylinder is going to be I equals mr squared. This is for a cylinder, again. And our mass, we know that weight is going to be equal to mg, which means that our mass is simply going to be weight divided by g. So this becomes wr squared over g. After this, we can now substitute and say 40.25 squared divided by 9.8. And this is going to give us a moments of inertia of 0.255 kilograms meters squared. At this point, we can find the force. So this force is simply going to be, from this equation, it'll be P equals I omega squared over 2D. And this is simply derived from this equation here. And at this point, we can substitute. So 0.255, 24 squared times 2 times 5. And the force here is going to be 14.7 newtons. So this would be P. And that's the end of the solution. Thank you for watching.